This video is going to cover 2.3 for college algebra, which looks at stretching, shrinking, and reflecting graphs and how you can see that in the equation. So first, let's look at vertical stretching. So the vertical tells us we're doing something up and down. Stretching makes us think we're going to stretch it out or get it bigger. It's going to look like this, k times f of x. So whatever that number is, we're multiplying the original points by k. That means our x-intercepts aren't changing because our y value is 0. So 0 times anything is 0. To do it mathematically, you take the y value of each point, multiply it by that number, your x value stays the same. So f of x is this red line right here. 2f of x means we take every y value and multiply it by 2. So on a graph, we'd say, hey, the y value of this point is 4. 4 times 2 is 8, so we would stretch it to 8, keeping the x the same. The second point here, our y value is negative 2. Negative 2 times 2 is negative 4, so we would stretch it to negative 4. This point, if you want to see it with the numbers, is negative 3 comma 2. So we would multiply this by 2 and get 4. Our x value stays the same, so we would stretch that to negative 3, 4. We said x-intercepts stay the same, so that's not going to move. This one, 4 times 2 is 8. And this last point, 2 times 2 is 4. So essentially, you just take each point, multiply the y-coordinate by that number, the k, and then draw your new point. If we connect those, that black line is the red line stretched out. So when you multiply by a whole number, we stretch it. Now I'm going to erase it, and we're going to do it with a fraction, 1/2. So this point right here is negative 6, 4. This is telling us to multiply y by 1/2. So half of 4 is 2. Our x stays the same, so that point becomes negative 6, 2. If I do this point, that's negative 4, negative 2. Half of negative 2 is negative 1. The x stays the same, so negative 4, negative 1 is the new point. And we're just going to do that for each. 2 times 1/2 is 1. X-intercept stays the same. 4 times 1/2 is 2. 2 times 1/2 is 1. And then we connect our new points. So when we're multiplying by a fraction, y times 1/2, we're going to shrink or squish our graph. Horizontally is the same idea, except now we're talking about left and right. So instead of the x-intercepts staying the same, the y-intercepts are going to. And just like with our shifts, we're doing the opposite inside. So we're going to take our x value and divide by k, because in here it looks like multiplying, so we do dividing. And for the horizontal ones, the y values stay the same. So f of x is our red. Let's do our 2. Oh, that's not a highlighter. Let's do our 2. So what we're doing is we're saying x divided by 2. So this point right here, 1, 2, 3, 4, 5, 6, 7, is negative 8 comma 4. We're saying x divided by 2, y stays the same. So that point becomes negative 4, 4. This point is negative 4, negative 4. Divide x by 2. So negative 4 divided by 2 is negative 2. Y stays the same. So that point becomes negative 2, negative 4. Intercept, y-intercept stay the same. So that one's not changing. This point, our x is 4. So 4 divided by 2 is 2. And this last point is 7. 7 divided by 2 is 3.5. So we draw our new shape. This time, our whole number squishes it. So this one's a shrink. Again, the opposite of what you would expect. pause the video, try the other one, check it in and see how you do. But essentially, what we're doing is we're going to do x divided by 1/2, which is going to stretch it out. So those same first 2 points, I'll even do them in the same color. -8, 4. -8 divided by 1/2 is -16. So we would change that to -16, 4. So 9, 10, 11, 12, 13, 14, 15, 16. So it'd be way out here. And then this point was -4, -4. And -4 divided by 1/2 is -8. So this point would end up here. Y-intercept stays the same. 4 becomes 8, and 7 becomes 14. Our new shape this time is very stretched out. So those are your horizontal and vertical stretching. So remember, outside, you multiply the y coordinate. Inside, so if it looks like this, you divide the x coordinate. That's the difference. Now, reflecting is like a mirror. We're going to flip the shape over something. So if red is our f of x, negative f of x, so negative times the y, or negative on the outside, is going to flip over the x-axis. We're taking all of our y's and changing the sign. So -4 becomes +4. +2 becomes -2. -2 becomes +2. Connect our new shapes. So when you have a negative in front, it's like multiplying your y by -1. That's one way to think about it. Or flip it over the x-axis. Inside, we're doing it to the x. So it's like saying x divided by -1, which essentially flips it over the y-axis. So -2 becomes +2. 0 stays 0. And 1, 2, 3, 4, 5, 6 becomes -6. So now we have our shape flipped over the y-axis. When they're combined, like multiple steps, multiple numbers, you just follow the order of operations. Some people do the whole thing at once. Other people do it in pieces. So I'm going to show you both. So we're going to say f of x equals x squared. That's the graph that's right there. Now we have these pieces. So order of operations, we have parentheses. So we would do that first. That's 1. Then we would do our multiplying. That's 2. And they're adding and subtracting. So we can do it all at once or in 3 steps. I'll start with the three steps separately. So the blue tells us to go right 4. So we take each of these dots and move it right 4. Then we do the purple, which means we're going to multiply all of the y's by -3. So this y is 4. 4 times -3 is -12. 10, 11, 12. 1 times -3 is -3. 0 times -3 is 0. 1 times -3. 4 times -3. So now we've done those 2 steps. Then the green tells us to go up 5. So we take each of these points and slide them up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the green would be our final shape, doing it one piece of time. Some people need to do it. Their brain can only handle one at a time. The other option is to do it all at once. So I'm going to take this point right here, and I'm going to go right 4. Then I'm going to multiply by -3. Then I'm going to go up 5. And there's my final point. Then I'm going to do the same thing with this point. I'm going to go right 4, multiply by -3, and then slide it up 5. So that's my final point. Then this one, I'd go right 4 times -3, up 5. It's my final point. Then this one would be right 4 times -3, up 5. This point, right 4 times negative 3, up 5. And that's going to be the same as that green one from before. So if you can do it all at once in your head, that's perfectly fine. If you want to do one at a time, that's fine. You just have to be able to tell me what your final one is. So if there's a bunch of colors, you would tell me what color is the final one. You could label them 1, 2, 3 on the graph. If you do it on a calculator, you can show me. Just you want your picture to show me what is what. That's 2.3. Let me know if you have any questions.